So machine learning engineer topped LinkedIn's 2025 jobs on the Rise list. And a lot of people are focusing on job cuts, plus an uncertain future for junior developers. However, the industry is also dangling nine-figure offers to snag all of the best minds in AI and ML. So to talk about this, I'm bringing in our guest, Fred Nganga. He is a data scientist and also an associate professor at Notre Dame. And he's also authored an excellent LinkedIn learning series on deep learning. So we're going to talk about the skills and strategies that are going to help everyone navigate this new way of working, how to break in nowadays, what sort of things you need to have in order to be there. So hello, Fred. How are you doing?
I'm doing good, Ray. Good to see you again. It's been a wonderful, exciting time that we kind of live in these days. A lot of stuff happening, and I'm looking forward to the conversation. I think it's going to be meaningful and very enlightening. Thank you.
I know it doesn't seem to be slowing down. We were talking about that right before the show. So we've gone
Yeah. Mhm.
through a lot of stuff recently. I know that I saw this sort of post from LinkedIn, and that there's been this huge talent surge in 2025. And interestingly enough, the sort of most important job that's out there right now is an AI engineer.
Mhm.
So that's really interesting. I sort of expected it, but I didn't know that the engineering part it was going to be the most popular. I know that you work with a lot of students who are studying machine learning. How do you see the market right now, and what do you think about what's going on?
Yeah, so that's actually pretty fascinating. And I think the key really is to be clear as to what an ML engineer is,
Mhm.
right? So there are different facets to careers when it comes to AI, data science, and so forth. And a simple way to think about an ML engineer is you think about the fact that you're trying to build a house. And so you have an architect who puts together the floor plan and all that goes into the house. So that's the design part of it. All right. So typically we think about those folks in the AI space as the data scientists in general, right? The ML engineer really is a person who comes in and actually puts those ideas into production, right? So it makes them reality. So I think a way to think about it is maybe a builder, right? Or a contractor. But the cool thing about this contractor is they don't only just build the house for you, they actually build it, monitor the house for wear and tear over time, and if anything goes wrong with the house, they come back in and actually take care of the problems. So it's almost like you have a contractor who's also a handyman, right? So that's kind of almost kind of how you want to think about it. So that's typically how you want to think about an ML engineer.
Hmm.
And so because the demand is so much more these days for companies trying to integrate AI into their workflows, into their businesses, strategically, there are a whole lot of ideas out there, but not a whole lot of people capable of implementing those ideas. And that's kind of what's going on here. So I'm
Hmm.
not too surprised about that, but it's interesting and fascinating to observe and see how that career path is evolving over time.
Yeah. So do you feel that this is perhaps some sort of like short-term blip, or are we going to see this for quite a while? How are your students feeling about what's happening?
No, I do not see this as a short-term blip at all. AI, the whole AI thing is not a fad. I know people have thought about that for some time.
Yeah, I'll say that.
It is not a fad, and it's not going to go away.
All right.
Yeah.
You do you, my friend.
I know. It's here to stay. It's here to stay. And so, yeah. So the key is there are different roles and different types of things that you can do as an ML engineer, and the key is to find your niche, right? To find the area where you can add value. And I talk about this with my students. One of the things I actually do at Notre Dame is in the School of Business, Mendoza School of Business. I am in my department, IT, analytics, and operations. I'm the faculty sponsor for the student club. And as part of in that role, part of what I do actually is keep track of placement. So I'm very aware of the types of jobs our students end up doing, how long it takes them to get hired, what types of companies tend to recruit our students, and so forth. And so a lot of times, again, the key when I hear back from our students that they've gone into industry is them talking about some of the just one of the things that they learned along the way being so critical in their career, something that they even think was going to be important. Oh, SQL. I took a SQL class, and so now all my work is around SQL, extracting data from databases. And they didn't think it was going to be important while they were students, but it's become the primary focus of what they do. Python, coding, the basic stuff, right? So data just all those little things. And so I do see a lot of skills, fundamental, foundational skills that become much more important for students in this field, depending on where exactly they find themselves.
That's interesting. So another thing that's happening is we've seen sort of a sort of the word is getting more complex itself, different kinds of models. We started out with a simple large language models, and then we grew up to reasoning models. And now with like the latest Grok release, we have multi-agents talking to each other, to determine like what the best sort of, course of action is. So we've got all these different announcements, researchers building new kinds of agents. What do you think is coming next in the industry? What's the sort of, what progression do you see for artificial intelligence?
Yeah, we are. It's interesting. This is an exciting time. There's so much going on. It feels like a fire hose sometimes, but if you're able to kind of shift or sift through the noise and and all that's going on, and kind of look at some of the interesting things happening, it's really exciting and fascinating. I see so many directions that things could go when it comes to future progressions and future directions, right? So one of the things that when we talk about agents, right, the whole idea is autonomy. I expect to see more autonomous, right, agents which are domain specialized, right, looking at specific areas, agents that are purpose built to assist doctors in the work that they do, right, agents that are purpose built to assist engineers or researchers in the work that they do. So these agents becoming much more specialized and domain aware, and also autonomous, right? So autonomy here being that the agents don't have to be told what to do. They already know. They are part of your workflow. They observe what you're doing every single day. They know what you do, what you're going to do the next day, and so forth. They're part of your schedule. So these agents kind of almost working as if they are an assistant, a research assistant, for example, just gathering information, getting things prepared, getting things ready, your lab ready for you when you come into work the next day. So that's one area that I see I see that actually in the near term, that's going to be possible. Another thing that we don't always think about when people talk about AI is the whole idea of on-the-fly learning. So a lot of AI models don't actually learn on the fly, right? They reason, but they're reasoning based on past knowledge. They're not integrating new information on the fly to reason and figure out problems. That's going to be fascinating to see models that eventually will be able to kind of like learn things based on stimuli or signals that are around them at that point in time, or even the conversation they're having with you. So that's another area where I see work being done, and I see some growth potential there, where we're going to see some fascinating improvements in that space. And another one that's happening right now is this multimodal capabilities of models, right? So we're seeing this when ChatGPT, for example, which is the most popular one everybody talks about, even though there's a whole slew of other things out there. But when it first came out, it was all chat, right? So text, right? So we're now seeing it kind of expanding into video, into audio, and so forth. So that's something that's happening. But then what I'm looking forward to really is the integration in real time of all those modalities, right? So you're not only switching, because right now we switch to audio, we switch to video, we switch to this. Like being able to interact both with text and video and audio all at the same time, that's going to be fascinating. So I see a lot of work going in these different areas, but these are some of the things that I think about. Reasoning models that are able to learn on the fly as they're collecting information, as they're interacting with their environment and with users, being able to have a long planning horizon and so forth, having models kind of like plan out things over a sequence of time steps and so forth. And again, being more integrated in modalities. Those are some of the fascinating. I mean, there's a whole lot of stuff out there, but those are the ones that I think about quite a bit.
True. Yeah, we've definitely seen the models sort of able to absorb different kinds of content, plus have access to more real-time data, not necessarily true real-time data. The models just went to a whole other level once they were given access to the web. I know they're really constrained by like their training data, since they have to be cut off at some point. But now they're just behaving differently now that they have access to the entire internet. And we even saw some news about this, with some of the models are now able to win like math and programming contests that they weren't able to do before. And I don't know that the sort of base models themselves have actually changed that much. I don't know what your thoughts are about this. I think that they have gotten these new tools and the reasoning kind of enhanced them, but the actual base models have been kind of progressing a little bit slower than I thought they would be. What do you think about that?
Yeah, so that's the thing too, and that's why it's important sometimes to understand, or it's important in general, not sometimes always, to understand the fundamental mechanics of how some of these models work. And so, yeah, you are absolutely right. The foundation models themselves that power some of these tools that we engage with have not changed as much as people imagine. So, for example, the example of like a model, like the models now being able to go online to search for data. They're searching for data to bring into their response. But that data is not actually part of the fundamental knowledge base. Like it's not really impacting what they know and how they interact with you. They're using that. It's more like a lookup, right? So it's like a RAG model, for example. It's going out there and say, oh, wait a minute, you want this? Okay, I'm going to go into the library and do some work for you. But it's not really absorbing that data the way we think about it. They're not being retrained on the fly to use that data. And so, yeah, so that's exactly what you're saying is absolutely right, is that these models are able to solve problems, but the fundamental basics of how they solve problems were pre-trained, and they're now applying that knowledge into a new space and so forth. And so, yeah, so it's fascinating to see even how much we push the boundaries of what these foundation-based models are able to do.
Yeah, and just all the additional capabilities. I think we had that what's called a DeepSeek moment where we had this model from China trained on supposedly much smaller, GPUs, and it was able to perform so well just because of the ability to, to not necessarily be any better, but the ability to sort of use that reasoning and use that sort of deep research and being able to be connected to tools. And we saw Manus, for example, sort of take advantage of that. So a lot of movement, not necessarily in kind of the base models, but some of the other things.
Yeah, speaking of that though, so I like that example you brought with DeepSeek though, because one of the things that I feel like here in the US at least, and I'm sure we have audience members from all over the world, but privilege sometimes and abundance of resources can be an impediment. And I think that's kind of how we want to always think about some of these things, right? Because I think, again, if you are developing tools in an environment where resources are much more constrained, you are much more thoughtful about efficiency. And I think that's kind of what really drives some of these advancements that we're seeing. Like, for example, DeepSeek was like a wake up moment for us. Like, hey, guys, we can do this with a lot less resources. But we were just so spoiled with having so much, and that we're like, oh yeah, it's okay. I don't have to, because there's so many ways to make models more efficient. Pruning, quantization, all these different things that already have been done and figured out. But how much of it we actually do when we build models, sometimes it's like, well, it's not worth it for me. I'm not going to spend that much time. But when you have folks doing this in places where they are much more aware of the limitations of resources available to them, they are much more innovative in how they do it. So I hope we learn a lot here in the US from some of these folks out there doing some very, very interesting stuff with a whole lot less.
Yeah, and I mean, I think that's the key. That I think we see this with software development, regular software development, that the hard drives get really big, the memory gets really large, and then you don't have to worry about cleaning things.
No, nothing. Yeah,
so
absolutely.
If you can do it with less, I think it's sometimes like a better constraint.
Absolutely.
So then you know that it's going to work, and the bigger CPUs, the bigger GPUs, the bigger processes. I think like what you're doing, at Notre Dame is really crucial. That you're teaching people the fundamentals of how to improve on these models, and just seeing that less resources can actually yield better results that multiply them to like larger things. But again, with all of this happening, we're also seeing this sort of strange thing that's happening with recruiting, and there's a lot of people who are super concerned about how it's a little bit harder to get a tech job. Do you feel like this is potentially something that is just conceptual, like it's not really happening as much, that it's really, people think that it's happening? Or what do you think about people who are just getting started trying to get a job? Because we're seeing that at the same time that hiring tends to be constrained, especially for people who are just getting in, we're seeing these huge salaries and offers from people.
Yeah, so this is a perennial problem and conversation that we have on campus as well. And when I advise my students, both those who are actively students and those who are graduated and working, I even have some of my students who come back who are trying to switch careers and they have all these questions about this, right? And so yeah, so there is so much going on out there, and it truly is harder right now for certain people in certain tech specialties to get employed. It's not across the board, but in certain areas. A lot of it's in computer science-ish type stuff and AI and so forth. And there is, I wouldn't say that there is necessarily saturation of talent. I think the issue really is companies are also figuring out that they can do a lot less. They can try to do a lot more with less, right? So the blessing of AI is also in a sense a curse of AI in that sense that it's one of those things where we're going through this inflection point where we're trying to figure out exactly how do we as humans add value to keep ourselves relevant, right? But for somebody who's just coming out of school or somebody who's new into the industry, there's several things to keep in mind. And yes, some of the more high profile jobs are harder to kind of land, but there are a whole lot of jobs out there. There's still a whole lot of jobs out there. It's more about the fit, right? So finding the place where you fit and you're able to add value. Some key things that I tell people to keep in mind is just a few things. Okay, well, when you're looking at applying for a job or trying to make yourself more marketable and so forth, recruiters and employers are looking for people that they feel are going to add value. So keep that in mind, right? They run a business, right? They're not there. It's not a club to hang out with and tinker and have fun with. It's a business, right? So they're looking at you as like, all right, what are you going to add to us, right? So they are looking at multiple people at the same time. And so how do you stand out? A few things I tell students to do and I tell when I advise people is have a portfolio of work, trying to develop something, right? So that people can at least look at that and say, okay, Ray, I don't quite know you yet, but I've seen some of the things you've done. So have some personal projects that you've worked on, simple things like just contributing to some open source library is another option there. So there are all different options out there. Kaggle competitions, that's another one right there. Even if you're not able to win, try and replicate something that has been done. Sometimes it's not about reinventing the wheel or creating a new wheel. It's like, can you even modify a wheel? Can I make a wheel? Can I make it a little bit better? Can I make it move faster? Can I make it move smoother and so forth? You don't have to come up with your own fresh solution, right? So also being aware of some of the frameworks out there. A big one that I always tell people to think about much more is MLOps, right? So think about the MLOps pipeline, right? So what does that really entail? A lot of people like the cool stuff. I build a model. And as we were talking about before, ML engineer work is not as flashy as I'm going to design a new algorithm. Is how do I maintain things that are operational? How do I put something that was designed into operation and into production, right? So those kinds of things. How do I keep it running? How do I improve it and make sure it's safe and secure and delivers what it's supposed to do? The final thing I also tell folks, especially my students in the business school, because they're technologists in the business school, which is kind of a little bit different, right? So we have this ITAO department, which is analytics, operations, and IT, right? And they're not computer scientists and they're not either finance students either. But the soft skills of being a technologist who can communicate complex ideas to non-technical stakeholders is underappreciated a lot of times, right? There is so much value in being able to look at something technical and be able to tell a story about it. And at the end of the day, I was a hiring manager for several years, and I don't always remember being impressed by people's resumes. I was a lot more impressed by who they were and the experiences that they've had and the way they talked about things, because that was what I was looking for. Like, who can learn, who can come into our space, integrate well with the rest of the team, and add value. 10 people have the skills that I'm looking for. One really seems like they can communicate well with the team and they know what's going on. So that's what I'm looking for as well. So again, all these different things. So you want to make sure that people know that you can add value. You've done some things, you're not just all head knowledge. and you also are able to communicate. Those are the things that I would say that people should probably keep in mind.
Very much underrated, and I
Yes.
totally agree with you. And I think that that's how you stand out, because if you know, when you are a recruiter, you're going through tons and tons of resumes.
Yes. Yeah. So
They all
many.
kind of look the same. They all have the
Yeah.
same credentials.
Yeah. Exactly.
And you know, if you think about the people who really make the big money,
Yeah.
they're not necessarily like the developers. You
Yes.
know,
Exactly.
Tom
Exactly.
Holland, probably
Yeah.
not the greatest
Yeah.
developer. Even
Yeah.
Bill
Yeah.
Gates, like in his time,
Yeah. Yeah.
maybe not the best developer,
Mhm.
but he could talk to developers for
Yeah.
sure,
Yeah. Yeah.
and he could translate business needs. And I think that
Yeah.
sometimes people underrate that. And if you look at what's happening in the industry today, with all these different companies making huge offers,
Mm.
who are they making the biggest offers to? Is it really going to be the absolute best developers and researchers? No, it's people that can communicate, that
Mm.
can build teams, that have those sort of interpersonal skills. So we've seen this, you know,
Yeah.
sort of almost
Yeah.
ridiculous amounts of money, nine-figure salaries to like
Yeah.
elite AI researchers. These
Yeah.
aren't just people that are great at research, though. They're people that, like you said, they
Mhm.
have these other extra skills.
Mhm.
But what does that do to the rest of the market and expectations for maybe beginning or mid-career ML engineers?
Yeah, so this has been astonishing to me. It's just I'm not even sure what's going on here fully, but I mean I know what's going on, but it just seems odd and ridiculous to me. But yes, this has so many implications. I mean I can go on and on about the potential implications of what's happening here. Um, so there's several things, right? I feel like when I think about that, that's an interesting question that you just asked there. I think about the pros and I think about the cons, right? So maybe I'll start out with the cons first, and I'll talk about the pros in a sense, because at first it seems like a negative thing all across the board, but I feel like there are some positive things as well. So on the negative side of it, obviously, this is going to put pressure on a lot of companies to now start to spend more, right? So you're talking about Meta, who's doing this. At some point in time, if there's enough brain drain from some of these other companies like OpenAI, Google, and so forth, they may try to. I mean, I think they already are doing that, trying to counter offer and so forth. And what
Mhm,
does that really do? That increases overall the cost, right,
mhm,
of their services, right? So that's pretty much what's happening there. So the overhead kind of goes up because now we're spending a whole lot more money to retain talent. In a sense, you can also think about a rising boat. A rising tide
mhm,
lifts all boats potentially, and say, okay, well, maybe that will trickle down, and then maybe the incoming engineers, and mid-level career folks may get a little bit of a bump because of this. Potentially, it could happen. I don't know, right?
mhm,
So that's one positive. What's one negative? One positive. Kind of both sides of the two sides of the same coin. Another part of it too, though, and I think I'm going to think about it from that perspective too, of each concept has a positive and a negative. The other part is expectations, right? And so with this inflow of resources, a company is paying millions of dollars now for talent. They're not paying it. They're paying it for, I mean, let me put it this way, they're paying it on purpose with the expectation there's going to be a return on their investment, right? And
mhm,
so that also from their perspective, from a purely financial perspective, sometimes can put financial some pressure, right, to shorten the development life cycle. Right, say, hey, we've pumped in this much money into this.
mhm,
We want to see something for our money,
mhm,
right? The potential negative of that there is obviously some shortcuts are going to be people are going to take shortcuts to try and get things out there as quickly as possible. There's going to be pressure to show something, whether it's good or whether it's bad, but it's at least something. It's going to be a lot of vaporware. There could potentially be some more vaporware out there because people are trying to show value for the money that they've been paid. But on the positive side, I also feel like when there is that competitive pressure, sometimes we have seen that people all rise up to the occasion. And I remember a few weeks, I think it's a week ago or so, I was reading something from the CEO of NVIDIA, Jensen, and he was talking about how he pays his staff very well. He's minted several billionaires as part of his C-suite, but he says he abuses. It's kind of a weird use of words. He abuses his staff to make him better. I was like, okay, I'm not sure if that's how I would want to lead, but what he was pretty much trying to get to was that he pushes them to the edge, right? So to kind of push them to innovate, to move. So he pushes them to kind of push themselves, to push the boundaries, and to get better and to build better products and so forth. And we've seen this. I mean, this was common at Microsoft for many years, and all that, some of the tech companies like Apple and so forth. There's always that competitive environment where people are trying to do the best that they can because of the pressures that exist within the culture. So that can be a positive thing. The other part I see as well is when you bring in a superstar, right? I think about, so one of my favorite teams are the Lakers, the LA Lakers, and I remember LeBron James coming into the team and so forth, and the ownership of the organization saying, "Hey, we're bringing him in specifically to win championships," right? So that's kind of what we're bringing him in for. It's not here to do anything else but to win. Mm-hmm. What happens in those environments a lot of times is that the presence of somebody like that can elevate everybody else's game, right? Mm-hmm. So you learn from them, you observe them, you see how they do things, you try to emulate them. And if they're good leaders, right, they're able to kind of bring the team along and help everybody get better. So I see the positives and I see the negatives in each one of these things. But again, the pressure to deliver, whether it's good or not good product. There's also the benefits of now working with somebody who's a superstar researcher. There is the whole idea of now the company has much more resources available for AI and data science work, and so which is a positive thing at the end of the day. But again, there are positives and negatives to this, I feel, and I'm not sure exactly if I know where this is going to really end.
Sure, I think like you definitely have seen this weird thing happening that it's causing a lot of chaos in the industry, and that there has been a brain drain in some of the other companies. Like you saw a lot of people potentially coming from Apple or Meta going after everyone, like anyone that's done anything, and that can be a little bit sort of stressful to the whole industry. We've seen companies like OpenAI have to delay their open source project, delay the release of GPT-5. Plus then you have other teams that are coming up with ideas that I think are so good. We have, I think that GPT-5 is like, I don't know, the next Marvel movie. There's really high expectations for it. And if it's not amazing, like it better be amazing. Other things have caught on.
I know.
Unbelievable. We're all going to be like, stocks are going to crash.
Yep.
We've already seen like Meta sort of suffer, and I think that's where his idea of I got bags of money that I didn't know what to do with it. I've been shoveling into the ground because I don't know what to do with so many things. Let's just use up some of that stuff,
Absolutely. It's so funny because I remember, I don't know if you saw the thing from Sam Altman, which is kind of funny. He said, I think he says missionaries versus mercenaries. I don't know if you ever saw that. I was like, okay, I don't know if you're the missionary, Sam, but we'll go with that. we'll go with that. But yes, absolutely. Yes, there is that part of it.
Nobody messing around anymore. I mean, I'm telling you, I imagine like Sam's probably digging in his yard to see all the billions are hanging out.
I know, I gotta go get some more billions.
Everybody's
absolutely.
Like looking in their couch for
I got
here, back with money.
Absolutely.
So moving on, what's your feeling about this whole conversation about AGI and ASI? So AGI being artificial general intelligence. Maybe you can explain the concepts a little bit, and then ASI. Artificial super intelligence. Maybe you can talk about the different sort of ideas there, and what do you think is going to happen?
So I'm glad you kind of try to explain what those terms mean, because I hear those being banted around all the time. That's something I've also heard a lot. What was it? I can't remember what year it was that some engineer, I believe at Google, claimed to be a whistleblower because he felt that the AI that we're building was sentient. I don't know if you remember this. I don't remember the details anymore, but I remember having that conversation in my classroom with my students. It was like a big deal for them. It's like, wait, is this true? Is it possible that the AI is sentient and it's in there, and yet we don't believe it, or what's going to happen with that? But so when we think about AGI and ASI, right? So ASI is AGI. I'll start with AGI. So AGI, artificial general intelligence. What does this really mean? This means that we are at a point where the machine or the AI is able to reason and act and solve problems and interact as a human, right? At the level of human intelligence. Pretty much, what does that really mean? That's not clear to everybody, right? So because there's no benchmark anywhere where we've listed out this is what it means to be human. All these things.
Like when people say agents, like there's
Yeah,
about
yeah.
10,000 definitions.
Exactly.
Nobody knows what it means or what you're talking about.
Exactly.
The AGI is very variable.
Yeah. Because even as humans, we have different levels of intelligence. So sometimes we see humans like, wait a minute, are you intelligent or not? So what does this really mean?
The whole YouTube category exists on this.
Exactly. And so that's kind of what I'm thinking about. So, okay, so when you think about it from that perspective, like AGI is a very squishy concept because there is no line where we say we've crossed into AGI. So if we attain what we think of as AGI, we may not even know it because, again, it may be happening in some aspects and maybe not in other aspects and so forth. So there is no one line to cross.
Yeah, I think that I remember years ago when we talked about the Turing test, and my father-in-law was asking me about that, and I thought we are way past that Turing. we are above and beyond. Now we've reached that squishy level that we don't know exactly.
We don't know.
Where it really is. But I feel like you could say that maybe we're there. The computers are now for reasoning. Like we've seen tools like ChatGPT Agent, some of the agentic browsers that you can give them a computer. Protected the computer with a mouse and keyboard, and they can go do things that are similar to what humans do. And great, honestly.
Yeah, absolutely.
But they're starting to be able to do jobs.
Do some things, yes, exactly. But that's kind of what I feel like. I think we should break that up into saying that I don't think there isn't an AGI point. We can identify certain tasks, right, and say when do computers or when is AI able to accomplish this type of task reasonably, and we feel comfortable letting go and not having significant human oversight, right? So that's the kind of thing I would kind of how I would approach this. It's like there are certain types of things that we do as humans. We should break them all up and say, okay, well, for this particular thing, we've achieved this level of intelligence and autonomy that I can allow AI to do this for me. When it comes to this, I allow AI to do this for me. But there is no one line in my mind across the board where we can say AI can do this. And when it comes to ASI, which is artificial super intelligence, that's even beyond. That's now pretty much saying that AI is much more intelligent and much more capable than humans. Well, what does that mean, right? So a car is more capable at moving fast than humans. There are all these tools that we have that are able to do things much more in a much more capable way than humans are, but they're specialized, right? They're specialized to do a certain thing, and that's what they do. And so, same concept. Can we create an AI that's able to solve math problems way better, any kind of math problem than humans? Yes, of course we can. Are we able to create an AI that can code better than any human, which we already probably have now? But again, there is no line in my mind that we're working towards. And I think what our focus should really be is how we integrate AI much more efficiently and effectively in our lives, right? So we have all these tools at our disposal today. It seems a little disjointed. How do we bring them all to really, instead of artificial intelligence, right, it's augmented intelligence in my view. How do we allow these tools or leverage these tools to augment and enhance what we already do as humans? And for the things that we don't care to do, allow it to take care of it for us. And when we come back, but at the end of the day, it's there to work for us and not the other way around. So that's kind of how I think about these things.
Maybe we've gotten to the point. I remember when I try to explain to my kids that are playing video games today and how rich their environment is. And I remember when I was a kid, it was like 8 pixels, one color. Or if you're lucky, or a paddle and a little pong and stuff. And they were like, it was fun. Like I actually enjoyed those old computer games.
We made the best of it. That's what we had. Yeah.
So and I think that we're kind of at those beginning steps where the tools are able to do some things that are very useful.
Yeah.
They're not really, the general intelligence usually to me means that they're able to do like almost anything.
Anything. Yeah.
And that not quite there, but I think we're kind of on the spectrum. And I do think that we're seeing the 8-bit pixel sort of beginning parts of that. But the next concept would be what people call artificial super intelligence.
Intelligence, yeah.
And of course, that there's so much about that people started betting on when they people can bet on anything. So they're trying to figure out when do they think something like AGI or ASI is going to be happening. Actually, they're talking about AGI here. But what do you think about that? Are computers ever really going to be sort of conceptually smart enough to be smarter than any human? I mean, you could say, I remember when they first started beating chess masters. I was living.
Yeah. That's been a while though.
Go masters. And that was such a much more difficult game that it took a lot longer to get there. Now we're seeing computers beating a lot of coders. They're not dominating yet, but that seems to be within reach. And you saw, I think Meta was saying that they feel like these things are happening. Like what's starting to happen now is, computers that self-improve on code that they've written.
Yeah.
So that's kind of interesting.
That's a big part. Yeah.
What about the ultimate goal where you create something that is so intelligent that I don't even know what you want to do with that. I saw that this old movie that I'm always referring to these days called Colossus. It's really old, from like the 1960s.
I haven't seen that.
It's about they give this computer basically they put it in a mountain, self-sufficient power, and the computer obviously does what a computer in a movie would do, take over the whole world.
Yeah, of course.
It connects to the Soviet version of the computer, and they start talking to each other. Okay. And then of course they try to shut them down, and they launch missiles. And great movie, but I'm saying, like, I feel like we definitely don't want to get there.
No, we do not. We do not. And that would be foolish.
The ending of that movie is Colossus, the Forbin project.
Okay.
The ending of the movie is really chilling. You got to check it out.
I'll have to write that down.
The ending, like at the end, I don't want to spoil it, but the computer has a speech that it gives, and it's very chilling. Like it's just chilling. And you're like, wow. I feel like sometimes you wonder, how did they know back then that what was going to happen about that today? But I don't know. Super intelligence. I don't know that we want to get there, but do you feel that it's even possible?
And again, like I said earlier, I don't know what that means in terms of it's like, because even the thing that you showed just now where people are trying to bet. So who's the arbiter? Who's going to be able to, who's the referee here? Who's the goalkeeper? Who's going to say, all right, we've crossed the line? What does that line look like? I don't think everybody has a different line. And I don't know if I feel like we have things, right? I mean, I think we have super intelligence the whole idea of artificial super intelligence, where it's all encompassing, all intelligent, and it's able to do everything for us, almost to me implies that we've given up, like we are no longer in control. And even if there is a time when that could be possible, I hope I'm not here for that. I just don't know if I want to be in a world where we are totally not involved in decision making, and where this tool that we created now is our God. Like we're now, because that's pretty much what that is, right? It's a super intelligence system, and how many of those do we have, right? So it can't be. It almost seems as if, like with the example you just gave with the movie Colossus, there has to be one, right, that makes a decision for everybody. Because if now you have competing super intelligences, now they're going to have different incentives and different objectives, and now there's going to be warfare between them, and we're just now where the grass. It's kind of funny because it's a East African saying that when two elephants fight, it's the grass that suffers. And it's kind of like we become the grass here, and even though we are the ones that made these things, and now they are the ones fighting and competing against each other, and we're just collateral damage. I hope I'm not here for that. I hope we don't have that, because that implies that they have exceeded us in all aspects, reasoning, logic, all of that, even morality and so forth. That is, I don't know. Maybe I'm being overly dramatic about it, but I don't.
It's so easy to think about the system like that and imbue it with a perspective that would be the antithesis to humanity. Maybe it's like nuclear weapons. Like you don't really want to use them. You maybe develop them, and you hope that nobody ever turns one of them on fully, because I don't know. All right, maybe I should switch to it.
I don't know. Yeah,
So
but it's fascinating.
I found the
Yeah.
article that you were mentioning today about
Yeah.
Meta
Oh yeah.
saying
Yeah.
that missionaries are
Yes.
going to be mercenaries.
Yes, that's it. Yeah. Yeah.
Yeah, and I
So,
think that he's
yeah.
talking about the people who have a vision for how to, what needs to happen in the world will
Yes.
sort of stay put at a certain point. How many, how much more money do you actually need, right?
Mhm.
And so, but it's ironic that the person saying it is actually Sam
Yeah. Yeah.
out
Yeah.
of
Yeah.
everyone. But
Yeah. Yeah.
yeah, so lately also we have seen this really strange things happening
Mhm.
with Sam Altman actually thinking about releasing an
Mhm.
open source model, while
Mhm.
Meta is trying to actually now
Developing.
considering doing the opposite, which is very weird.
Mhm.
So what do you think about this race between open and closed source models? The sort
Yeah.
of the different companies are doing that. The Chinese are really pushing forward, and
Mhm.
they're definitely ahead in open source. But
Mhm.
now, I was really surprising is really Meta, who actually really
Yeah.
championed open source, kind
Mhm.
of thinking like, well, maybe we need to go closed source. Like, why do you think that is? And then who do you think wins at the end?
Yeah, it's interesting that Meta is the example you gave, and Meta is the one that's been pumping a lot of money into hiring folks, right? And that's kind of going back to what I was saying before, ROI, right? So I'm spending all this money on getting the best talent. What am I going to get for it? All right.
Mhm.
And so, from a business perspective, it makes sense to say, I am going to spend a lot of money so that way we can build better tools and better solutions and maintain this competitive advantage over everybody else. And so if I'm focused on that to try and maintain an advantage over everybody, I'm not going to open source my solution. I spent all this money to build it. I want to get something for it. So that's the benefit on the closed source side of things, right? Control and potentially profits, right? So they have control over how their tools are used. They can control in what environments and their tools are being used and who can use those tools. And so that helps from the business side perspective on their side of things. On the other side, right, the open source approach here is interesting to see OpenAI going that way because, again, they have typically just provided APIs for most of us to be able to interact with their tools. And as you mentioned, DeepSeek was able to release their tools out there so we can see the weights and so forth for the models that have been built. I think that's a direction that, for the most part, we should really be going, is more and more open source solutions. And we saw this many years ago, too, with software, right? So we had the same thing happening. It's like a divergence in the fundamental strategic idea or fundamental idea of how should software be developed and deployed. The obvious benefits of open sourcing is obviously you have more eyes on your solution, right? You have people being able to test your products. They're able to improve it. They're able to kind of find bugs in it and fix those bugs and then publish the solutions to everybody and so forth. And also helps with cost, right? So new players and new businesses and so forth who are coming into this space are able to leverage open source tools and then build on that. You never know where innovation is going to come from, right? Because if everything is all closed source, it really pretty much implies that only those with money and resources are going to be able to innovate. So again, that's some of the benefits. The other thing we haven't really mentioned is I don't know if you saw the recent action plan released by the current administration and the White House talking about how we can kind of win the race in AI. And there are several areas that they talked about and they focused on. Interestingly, it's kind of interesting that Meta is going closed source because one of the areas that the administration actually talked about was trying to encourage more open source, right? More open source models. And they were going to try and encourage more small businesses and mid-sized businesses to focus on adopting open source AI models rather than closed source solutions. And so that's the direction they're trying to move. And I think China has been an example for the US to kind of look at and say, hey, how can we enhance our competitiveness? We are still ahead, but very slightly. If we take a nap for too long, we are going to wake up and find ourselves way behind. And so we're trying to now wake up and be much more aggressive in what we're doing in that space. So, but I think that's the direction that we should be going. But again, I understand the need for some closed source solutions. I also think that sometimes the fear of having a super powerful solution out there for anybody to use however they want can also be a problem. So I don't know if I have a full answer or a best recommendation for how to approach this, other than maybe a hybrid approach where the most powerful solutions are managed carefully, and as new solutions come in, older ones are released and open source so that people can build on that and learn from that and innovate from there. So that's maybe the hybrid approach, maybe the way I would think that we should be going in this regard.
Yeah, it almost feels like because China has gone open source, and also even because of the constraints, they've been able to sort of catch up much faster. And I think that the other thing that we're seeing that's very strange and that I didn't expect was this kind of problem with energy and cloud costs rising so much. I didn't really expect energy to be a problem, and I think that now that is kind of gotten so important that we see Elon importing like a power plant, and we see a lot of energy development in China, which I think you really do need, and we're definitely hurting in that area. What do you see in terms of solutions to this kind of model energy crisis?
Yeah, and this is something that's been since the last 10 years or so. Researchers have been looking at different ways to improve on this, right? So there are several directions that the companies and even organizations have been going, or even colleges and universities have been going to try and mitigate for this increasing demand of energy. So one is just more efficient hardware, right? So that's been one of the things that has been happening. Even NVIDIA has been focused a lot on that. The more recent GPUs, they've been trying to find ways to have them use less resources for compute, right? So trying to be able to do more with less power. And so that's one thing that's happening in the industry, because everybody can see where this is going. There are finite resources. We're not going to have, well, we could maybe nuclear fission or something, develop something where we have infinite energy source, but we don't have that right now, right? And so in the absence of that, we have limited resources. And so we have to find a way to do more with what we have. Another area where I'm seeing improvements, where people have been working on, is just efficiency of algorithms. So rhythmic efficiency. So there's several things, and I mentioned some of these earlier, like the pruning is one example, right? So you build a neural network with so many nodes and so many weights and so forth. You can prune it, so where you kind of reduce the size of the neural network without losing much in terms of performance. So there's also something called quantization, where what you're really doing there is reducing the precision of the computations, right? Without, again, losing much in terms of performance, right? And then people are also coming up with different types of neural network architectures that are much more efficient in how they solve problems. The other part of it is something that this is interesting, because my PhD dissertation was around cloud resource optimization. And this is something that's now becoming more and more of a thing, is cost management. So a lot of AI solutions are deployed in the cloud because it allows you to be able to scale up and down and manage load and all those kinds of things. And so one of the things that people are now focusing a lot more on is resource utilization, maximization. So like trying to make sure that I am only spinning up machines that I need for what I need to do at that time. And when I don't need anymore, I turn them off, right? So batching, scheduling, all those kinds of things, auto scaling. These are things that people are doing out there to try and manage resources much more efficiently. We have the tools, and with the will, we should be able to kind of manage some of these a little bit more. I always give the example. I think it was the University of Denmark. I may be wrong about this again. They did a study. I think it was GPT, the first GPT. They did an estimation that the amount of carbon that was used to train that first GPT is about the same amount of carbon that would be expended if you drove a car from Earth to the moon and back.
Oh, wow.
I know. I don't remember the details of this, but I do talk about this in my class. I was like, wow, that's a lot of energy being used. But that's not even GPT-4 things that we have today. But this is the old original, I think it was GPT or GPT-2 or something like that. But anyway, that just tells you how much how much resources are being consumed just to train these models and so forth. So yeah, so people are working on different aspects of this problem, and I'm hopeful that we are going to come up with better solutions for it.
Yeah, and I think that in these days where education sometimes gets a bad rap. I mean, if you think about the people who are performing the best in driving sort of this next generation, it's the people who are highly educated, college, PhDs. So we definitely need to encourage people.
Absolutely.
That's why I'm so glad that you're here. Representative from Notre Dame, sort of talking about the importance of not letting that go, because I think it's really where the future is going to be. Highly educated researchers and
there's a lot going on in that space. Absolutely.
So anything else you want to talk about before we go? Anything you're working on that could be pretty cool? I know you just finished this great series. Everybody should check out on LinkedIn. So I'll definitely add that to all the links for the chat. So anything else you want to say?
I think, as you mentioned, education, not even necessarily education in the classroom, but just awareness. So I think we all need to educate ourselves, right? I think we all have a responsibility to be aware of what's going on out there. The reason why I say this is one of the things that we don't have in this country, at least as far as I'm aware, is a comprehensive privacy law or how we manage data. I know Europe tried to do GDPR, and there are pros and cons to GDPR and there are a bunch of research on how effective it is. In fact, actually, some of my colleagues and I have a paper that we're working on around that same concept of how effective or how uniform are the laws being implemented. The reason why I say this is it's a privilege to live in a democracy where we have lawmakers who are quote unquote accountable to us, right? And so, and if we are, if we care about how our data is being used, if we care about how these tools, like we're talking about ASI and AGI, if we care about the direction and trajectory of all these tools, we should be more aware and informed about what they do and what they can do, so that way we can inform or encourage those who make policy, right, to be able to be smart and thoughtful in how they make policy to the benefit of all of us. And that's kind of what I really feel like is one of the things I always tell people, my students all the time. I want you guys to leave with an ethical mindset towards all these tools that we work with. They're cool, but they can also be very, very dangerous. There's a whole lot of stuff out there. One of the books I have my honor students read is Weapons of Math Destruction. It's one of the books out there. It talks about how, this is again older, but it's a pretty cool book because it talks about the potential problems of algorithms. So again, that's one of the things I always tell people all the time. Think about the ethics, cool tools, flashy tools, wonderful things we can do. Always think about the human impact. What exactly? Yes, thank you. Yes. I'm sure she's gonna love the fact I'm Kathy O'Neill is gonna love the fact I'm plugging her book. But yes, it's a good book to read. And one of the chapters I have us even reading that book is how college rankings came about. I don't know if most people have no idea how college rankings came about. This book talks about it, and it's fascinating and eye-opening to even think about that, because it's relevant to us as a university, because we always think about rankings at Notre Dame and in the School of Business and so forth. So, but anyway, think about the ethical implications and the human impact of these tools, and the way to be useful in that space is to be educated, to be aware, to make yourself more informed as to what it is that's going on out there. So that's kind of what I would leave the audience with. Think about those kinds of things beyond just the coolness of the tools.
Well, thank you so much for being here. I really appreciate all your insights. It's really great to talk to somebody who, I think everybody is interested in learning more, not just about the technology, but then all the work that you're doing, preparing that next generation that is going to lead the way in AI. So thank you so much for being here.
Thank you, Ray. It's been a pleasure. Thank you so much. I look forward to talking to you later, okay?
All right, take care.
All right, bye-bye.